السلام عليكم ورحمة الله وبركاته. Thanks for joining and welcome to this revision session. قول بسم الله. We have some revision questions, so let's start. Bismillah. Okay, the first question is, can you see the screen? شباب? See the screen. Okay, the ideal gas law best describes the properties of which of the following gases at 0 degrees and 1 atmospheric pressure. So he's asking me about the ideal gas, and the ideal gases, as we know, has no forces of attraction on each other. There is very weak forces of attraction on each other. So the volume and the gas that I need to choose must have the smallest mass of them, so that the attraction forces will be less. Because all of these are non-polar molecules. So since they are all non-polar, then the attraction forces between them will be only for LDF. And the strength of the LDF will depend on the number of electrons. So if I want the intermolecular forces to be weak, then I need the number of electrons to be less. So I have CH4 as the one which has the least number of electrons. So this one will have the weakest intermolecular forces. This one will be looking like the ideal gases the most. The second question is a regular question: why PR2 is a liquid and Cl2 is gas? We know that also the answer to this one lies in the same reply. The PR2 is a liquid and Cl2 is gas. Both of them contain only one type of intermolecular forces again, which is the London dispersion forces again. And again, the number of dispersion, the strength of the London dispersion forces in them depend also on its electron cloud. And since this one has more electron cloud and more polarizable, so this one will have stronger attraction forces. That's why it will be available in the liquid form, while this one will be available only in gaseous form. This will be available only in gaseous form. Just share the link just in case. Okay, the next question is a series of standard solutions containing red dye was made by diluting a stock solution and then measuring the percent transmittance of each solution at 505 nanometer as a greenish blue color. The results after conversion are shown below. So I made a curve between the concentrations and the absorbance, and I was asked that the absorbance would determine to be 0.40 at 505 nanometer for a solution with unknown concentration, and I need to find the number of moles of this solution. So again, because he has given me the curve already, so I can just simply look at 0.40 and find the concentration at that. He has given me the curve. I can find the concentration from the absorbance. So I'll just go and make a straight line in the exam between this 0.40 and the curve. Then I will go down. Then I will go down and complete the curve, complete the line like that, and find my number. Of course, my drawings in the exam will be more accurate. Then I will find the concentration. When I find the concentration, it will be almost 0.25. So concentration is equal to 0.25 molar. Where did you find it from? Only from the graph. So absorbance is here, the concentration is here. So since absorbance is here, concentration is here, concentration is equal to 0.25, and he's not asking for the concentration, he is asking for the number of moles. So simply the number of moles is equal to the concentration multiplied by the volume, and the concentration we have found as 0.25. This is general revision for the people who are coming late. This is general revision. So 0.25 molar multiplied by the volume. And what did he say about the volume? the volume is 100 ml sample, so it will be 0.100 decimeter cube or 0.100 decimeter cube or liter. Then when I multiply this together, I will get 0.025 as the number of moles. The next question is a very common question that comes in the exam also. A mixture of carbon monoxide and oxygen is placed in a container as shown below. A reaction occurs forming carbon dioxide. Draw a diagram to represent the content of the box after the reaction has proceeded as completely as possible. Right. He said the reaction here is between carbon monoxide and oxygen. And the product, as he said, is carbon dioxide. So this is the product, this is carbon dioxide. We need to balance this equation. This has 1 oxygen and 2, so 3. So here is 2, so I have to make this even number. I will multiply this by 2. So 2 carbons and 2 oxygens. Now it's 2 oxygens, and here 2 oxygens, so 4. Now everything is balanced. What did we say we have here? A mixture of carbon monoxide and oxygen. And he said this is most probably is the carbon monoxide, because it has 2 different shapes, and I have 2 moles here, and I have 3 moles here and 4 moles here. In my balanced equation, there is 2 moles reacting with 1 mole to form 2 moles of carbon dioxide. Then what is the number of moles actually? I have here 4 moles of carbon monoxide. And how many moles of oxygen do I have? Mr. According to the ratio, the 2 moles should react with 1 mole. So the 4 moles will react with how many? It will react, the ratio is 2 to 1. So it will react with half the amount, which is 2. I get this with the cross multiplication. So I'm supposed to have 2 moles of oxygen only. This is the 2 moles of oxygen. While in fact, in the drawing, I have 3. So I have 1 excess oxygen here. I have 1 excess oxygen. And how many moles of carbon dioxide should be produced? According to the ratio again, should be 4 moles of carbon dioxide, because the ratio is 2 to 2, so 4 will produce 4. Now he's asking, draw the diagram to represent the content after the reaction has proceeded. So you need to see the products. What are the products? I will draw this is a very common question, so I will draw the box like that. And then inside the box, I will draw carbon monoxide, so carbon this time, so I have carbon dioxide, this is 1 carbon, and 2 oxygen atoms attached here. If the carbon was the dark one, because the light one is the oxygen, so this is carbon dioxide. And how many times it's repeated? 2 times. No, it's 4 times. The 4 will produce 4. So I have to repeat this 4 times. So I will draw this 1, and then 2, and then 3, and then 4 times the carbon dioxide is produced. But take care, there is something excess produced here. So it's not only the carbon dioxide. You said I have 1 excess of oxygen. We have to draw this one also in the products, because this has to be reacted with 2, 4 molecules should react with 2, but in fact I have 3. So this excess one is going to show up here at the end. So excess oxygen 1 should show that. So the product is 4 moles of carbon dioxide plus 1 excess mole of the oxygen should be drawn in the full products. Again, if you get any question like that in the exam, you have to make the ratio, the balanced equation, and then make the ratio according to the number of moles that you have in your reactants, and then see if you have anything in excess, because this will show in the final products. And then draw the excess plus the normal products that you have already according to the ratio also. So another question, number 5, based on the structures shown below, which compound will have the higher boiling point and why? So I have 2 structures here. Both of them contain N and CH3. So can any of these make hydrogen bond or dipole? I can see that this one can make hydrogen bond. This one cannot make hydrogen bond, although we are very tempted to say that this forms hydrogen bond, but the nitrogen, one of the characteristics of the hydrogen bond is not available, which is it should bond to the hydrogen atom directly. If I looked here, I will see this is bonded to carbons, not hydrogens. And we said we have 3 conditions. It should have hydrogen atom. The hydrogen atom should be attached to an oxygen or a nitrogen or a fluorine, and should be attached directly only. But here the nitrogen is not attached to the hydrogen, it's attached to hydrogen through a carbon. So this does not form hydrogen bond. What kind of bond it has? It has only LDF. And this one has attached to the hydrogen directly, so it can make a bond with a similar molecule. It can make a bond it can make a bond with the hydrogen bonding. Okay, so it can make a bond between this nitrogen atom, which is partially negative, and this is partially positive. So this one will come to make a bond with this one, and the hydrogen can make a bond with another molecule. So it can make a bond with this hydrogen. So hydrogen with the nitrogen, and the hydrogen will attach to the nitrogen of the other molecule. So this one has LDF plus hydrogen bond. So this one, of course, will have stronger intermolecular forces, and so have stronger or higher boiling point, and that's how it's explained. The next question, reaction between nitrogen monoxide and carbon dioxide is NO2 plus COG plus NO plus CO2. The elementary steps of a proposed reaction mechanism are, this is the steps. Predict the rate law for the overall reaction that's consistent with the proposed mechanism. Inside the rate of the reactions, we said that there is no relationship between the rate of the reaction law, between the rate law and the last part is the coefficient. So there is no relation between the rate law and the coefficient, except in one thing. No relation between rate law, except if you are talking about slow steps. If you are talking about the slow rate determining step. Rate determining step. This is the only thing that there is a relationship between the number of moles or the coefficients and the rate law. So what should be the rate law? The rate law will be the same as the rate determining step. Which one is the rate determining step, the slow or the fast? The slow step is the rate determining step. So it says that R is equal to K, and it depends on the reactant. How many reactants are there? There is only one reactant, which is NO2. And this is to the power of what? Mister, you said this is a slow. So in this law, it depends, the coefficient is the same as the rate law. So it will be to the power of 2. Again, for the people who did not attend last time, I'm saying that the only time that the coefficient is related to the number, or the number of moles related to the rate law or to the power, is in the slow steps or the rate determining step. And this will be consistent with the proposed mechanism. So if the mechanism is correct and this is the rate determining step correctly, then the number of moles here will come as a power here. Like, what effect will increasing H plus at the constant temperature have on the following reaction? So if I increase the concentration of H, what happens to the rate of the reaction? Increasing the concentration of any of the reactants will increase the rate of the reaction. Why this happens? Simply because it increases the frequency of collisions, right? Increases the frequency of collisions. So the higher the frequency of collisions, the higher the rate of the reaction. When you increase the concentration, also the same happens when you increase the temperature or the pressure, or if you are adding a catalyst, the rate of the reaction also will increase. The decomposition of O3 in the upper atmosphere is presented by the following equation. The ozone reacts with oxygen to form oxygen gas. The suggested mechanism for the catalyzed reaction is these two steps. Step number 1 is the slow step, and the fast step is the second one. What is the catalyst? Let's remember together. What is the catalyst? So there are 4 things that we should know. The first thing is the catalyst. The second is the intermediate. The third is the reactant. and the last thing is the product. ايه الفرق ما بين الاربع حاجات دول؟ What is the difference between these four things? So reactant is substance that is appearing at the beginning of the reaction. So at the start of the reaction, this is the reactant, and does not appear at the end. So for example, I have oxygen in the form of ozone. I can see this at the beginning of the reaction, but I don't see it at the end. I cannot see any O3. So if you can see it at the beginning as a reactant and you don't see it in the products, then it is a reactant. طب انا عارف الكلام ده يا مستر. But خد بالك when you are talking about the final reaction. So this is the net reaction. So O3, I can see it here. I don't see it here. So this is a reactant. What about the product? The product is something that I don't see at the start, but I see it at the end. So for example, oxygen O2. This is a product. How do you know it's a product? I cannot see it at the beginning. There is no O2 at the beginning, but there is O2 at the end. So it is a product. So O3 is a reactant and O2 is a product. Okay, what about a catalyst? What is a catalyst? A catalyst is something that I have. Do you have a catalyst? What is the catalyst? Something that I put with the reactants and come out with the products. يعني هو عامل زي الرياكتنت ان هو بيبدا من البدايه. It starts and it ends. احنا عارفين ان هو it's not consumed صح؟ It's not consumed. At the beginning you find it and at the end you find it. فين هو يا مستر الكاتاليست؟ The O2, the NO. This NO I can see it with the reactant صح؟ هل هو reactant ولا catalyst؟ It's not a reactant because if it is a reactant what should happen at the end? It should disappear. لكن انا لسه شايفه هنا صح؟ I can still see it here. So since I can see it at the beginning and at the start and I can see it at the end, it's called what? A catalyst. Like who? Like NO. ايه الفرق ما بين الكاتاليست والreactant? الكاتاليست I see it at the beginning and I don't see it at the end. It disappears at the end. اتحولت إلى product. لكن الكاتاليست زي ما بيدخل زي ما بيخرج. It goes in and comes out the same way. طب what about the intermediate? What is the intermediate? The intermediate is substance that's produced in the middle of the reaction. So it's not at the start and not at the end. ازاي يا مستر not at the start؟ يعني لا موجود في الأول ولا موجود في الآخر. It's something which is produced in the middle of the reaction in one of the steps and then disappears. Like what? Like what? Like the NO2. NO2 is produced here. هل كان عندك NO2 في reactants? No, it's not there in the reactants. طب هل هي موجودة في البرودكتس ولا موجودة في البرودكتس؟ اختفت خلاص. So something that's like NO2, it's not in the beginning, it's not at the start and not at the end. ظهرت في النص واختفت. So if your substance starts at the beginning and does not show at the end, it is a reactant. If it's not at the beginning and it shows at the end, it is a product. طب if it is at the beginning, at the end, both of them, it is a catalyst. If it's not at the beginning nor at the end, it's only in the middle, يعني ظهرت واختفت, it is the intermediate. So where is my catalyst? The answer is my catalyst is NO because it's showing at the beginning and also at the end. If I started with 1 gram of catalyst, how much do I end with? I end also with 1 gram. The amount does not change. طب draw the potential energy diagram for the decomposition of O3 in the presence and absence of catalyst. Let's try to draw this. If I need to draw the graph, if there is a catalyst or not. So this is the energy, this is the potential energy, and this is the time. Did he mention anything about this being an exothermic reaction or endothermic reaction? This is the potential energy, and this is time. Did he say it's exo or endo? The decomposition is in the upper atmosphere is represented by the following equation. The suggested mechanism is so and so. The decomposition is in the presence and absence of catalysts. He did not mention anything. Identify. Okay, so just let's imagine that this is an exothermic reaction. So I will start with my reactants and I will end with my product. So this is my product. And this is the hump at the beginning. At this one, this is the absence of the catalyst. This is the absence of catalyst. There is no catalyst here. There is no catalyst here. So what happens when you add a catalyst? Can anybody tell me what happens when you add the catalyst? How the curve is going to change? How the curve is going to change if you add a catalyst?
Be lower.
So the activation energy will become higher or lower?
Lower.
Yeah, the activation energy will become lower. So this is the activated complex if there is no catalyst. This is the activation energy. It is from here to here. No, this is the activation energy from here to here. From the reactants until the intermediate or the activated complex. What does the complex do? The catalyst do? The catalyst will lower the energy of the activation energy. فبدل ما تبقى هنا تبقى هنا. It becomes here, for example. So how does the curve look like now? Instead of the curve coming up here, هيبقى لغاية هنا بس. So it will be here. This is in the presence of the catalyst. This is in the presence of the catalyst. So every time he's double, لو كان يا مستر endothermic reaction, you will do the same thing exactly. So just draw the curve. Again, the line, energy, and the time or the progress of the reaction. The reactants again, the products again, the products should be higher because this is endo. And this is the uncatalyzed reaction. So this is the uncatalyzed reaction. The same, but it's higher, the products. Like what to do in order to draw it lower with the catalyst? This is with no catalyst. How to do it with catalyst? Make it lower activation energy, so it will become lower. Any point lower you can choose. There is nothing specific. He did not ask us for any numbers. Then I will draw it lower. Then it will come down at the same. So starts at the same thing at the reactants, no change. Ends at the same thing at the products, no change. The only change is that the activated complex here is lower. So the activation energy is lower. بدل ما كانت from here, from point X to point Y, it become from point Z to point أو X to Z. شوف المسافة بتاعته قصرت ازاي. This is the distance now. So the activation energy become lower. That's why when he asks us, how does the catalyst work? So how does the catalyst work? The catalyst work, how does it work, Yassine? What I will say?
Lowers the activation energy.
Okay, so So catalyst works by providing an alternative pathway that has a lower pathway that has a lower activation energy. فادتني طريق تاني، قالت لي الطريق ده صعب عليك and it is very hard, you cannot reach from here, الانرجي بتاعتك قليله مش عارف توصل لغايه هنا. Okay, take an activation energy which is lower activation energy. Okay. So either it's here exo or endo, you can draw it ومش مطلوب منك انك تعرف certain number. You can just draw any point which is lower than the uncatalyzed one. And don't forget to write, to label the absence of the catalyst and the presence of the catalyst. Or you can just say no catalyst or uncatalyzed reaction, whatever word is suitable. This all have the same meaning. Uncatalyzed reaction, and then label here, this is the catalyzed reaction. Yes, Nadeem, tell me.
So what's this paper that we're doing? Like the questions?
This is a mixture of questions. The mixture of questions.
Like it's a mixture from you? You made the question?
Yes, it's a mixture from previous exams. It's from previous exams. Okay.
Of which chapters? 12 and 11?
This is mostly for the last four chapters, but including some from the beginning, but mostly from the last 4 chapters.
Okay, sir. Thank you.
Okay. Right. The next question is asking, where were we? Consider the phase diagram below. This is the phase diagram. Just to remind you, this is the place where there is the solid. This is the place where there is a solid phase. This is the place where there is a liquid phase. And this is the vapor phase or the gas phase. Okay, we said that if you are in any part, if you have a temperature and a pressure that makes you fall in this area, then you are in the solid phase. And if you are having a temperature, so if your temperature increased a little bit and you were here and your temperature increased, so on the x-axis you move to the right, so you reach here, so you change from the solid into the liquid. If your pressure increase, if the temperature increased a little bit more, you will move from the liquid to the vapor or the gas. Also, if you are a gas and you decreased the temperature, so the temperature, the x-axis goes from the right to the left, you change to the liquid and then you change into the solid. If you also decrease the pressure, then you can be also pressurized and change from a gas into a liquid. Okay, so your position or the physical state of the substance depends on its temperature and its pressure. Mainly the pressure will make effect only if it is in the gas phase, because this is the only phase that you can change the physical state by pressurizing. The only phase is the gas. Okay, let's see the question. Consider the phase diagram below. What is the normal boiling point of this compound? What is the boiling point, Ya Abdullah? Boiling point means you are moving from what phase to what phase? Boiling point.
From liquid to gas.
So good, from liquid to gas. So let's imagine that you are here. Let's imagine that you are here and moved to a gas. Now he asking me what is the normal boiling point. So my temperature that you are asking me will be on any point on this line. It will be on any point on this line, because in any area, this is the borders in which you pass from the liquid to the gas. So it can be here or here or here or here or here. So which one I'm gonna use here, mister? I'm gonna use the normal. What is the meaning of normal, Julian? Means the one at which there is 1 atmospheric pressure. So the boiling point is the temperature that you change from a liquid into the gas. And the normal boiling point is your boiling point when your pressure is what? 1 atmospheric. So I'm going to choose the one that's what? I'm going to choose the one that's what? The one that's at the normal boiling point, means at 1 atmospheric pressure. So I will go for the number 1. Where is the atmospheric pressure? 1. So I will go for the number 1. So I'll go and make my line from here. And then I'll go at the temperature. So I will go down until I reach here. So what is my boiling point? It's 100. This is only. طب ليه يا مستر ما اخترتش أي نقطة من النقط التانية؟ I have to choose a point that's at the 1 atmospheric pressure. طب what is the normal freezing point? freezing point المرة دي يا جوليان أنا ماشي منين لمنين؟
Liquid to solid.
Liquid to solid, good. So I'm moving from here to here. So I can be on any point here, right? I can be in any point of here, but I will choose what? Normal means the one that intercepts with the 1 atmospheric pressure. So I will go here and then see this point. The one that intercepts with 1. Then I will go down again and see my temperature. What is my temperature here? According to the curve, if I have a good curve, it is 70. It is 70. خد بالك ما يجيش واحد يقول لي مستر this is water, it should be 100 and should be 70. I never said that this is a water in any place. So don't assume it is water. مش عشان هو بس التمبريتشر بتاعته 100 so it is water. You have just to follow what is on the curve. والله الكيرف بيقول لي هنا so it's almost 70 degrees Celsius. خلاص I will follow that. In which state will the substance be at 120 and 1 atmospheric pressure? So I'll just follow the numbers. 120 and 1.5 atmospheric pressure. So this is 1.5 atmospheric pressure. And where is the temperature? Just go until you reach here. So I can see that this is inside which one, ya Mariam? It will be here inside the liquid phase. Okay, so I will be inside the liquid phase. And since we are in this question, when احنا جينا هنا, I'll just remind you what is this point. What did we say about this point? This is called what? This is the triple point. This is the triple point. What is there in the sides of triple point? There is equilibrium ما بين 3 phases. يعني أنا واقف في النص هنا ممكن أختار أروح في أي حتة. لو مشيت كده أروح للliquid. لو مشيت كده أروح للsolid. If I went like that, I will go to the vapor. This is called the triple point. This is equilibrium between the 3 phases. the three phases between solid and liquid and gas. طب if he asked me, Nadim, about this line or any point on this line, I will tell him what is there. So is this liquid or this gas? I will, for a dot here مثلا هقول له this is what equilibrium between solid and gas. طب if he asked me about any point here, I will tell him this is equilibrium between liquid and vapor. It's neither liquid neither vapor. It's equilibrium. يعني ايه equilibrium? يعني there is happening condensation and evaporation. If you evaporate it, you move like that, and if you condense it, you will move like that. But you are here, so you are in this point. So the rate of evaporation equal to the rate of condensation. So you are at equilibrium. ولو سألني على أي point here, I will call it what? Equilibrium between liquid and solid. What happens, Yasin, when you go from this point to this point directly? What happens? What do we call this? From here to here. What do I call it? This physical change, I call it what? From solid into gas directly, I will call this sublimation, right? I call it sublimation. This is changing from solid into gas directly without passing. عشان كده في substance بتاعتي تعدي من السوليد للجاز على طول من غير ما تروح للسوليد والليكويد والجاز. So directly is sublimation. طيب. I have a sample of cashew was burned in a calorimeter containing 1,000 grams of water, and the temperature of water changed from 20 to 25. In another experiment, 5 grams of the sample of marshmallow was burned in a calorimeter containing 2,000 grams of water. Temperature of the water changed from 25 to 35 based on the data which has greater energy content. So I need to know which one has more calories or more energy content, 1 gram of cashew or 1 grams of marshmallow, and specific heat capacity is 4.2. How can I know this, Mr.? Anybody got a suggestion? I need to know how much heat will be released. So I will use my normal equation. What is my normal equation? I need to find the amount of heat produced. How do I find the amount of heat produced? The Q, right? Q is equal to MC delta T. What is the mass in the first one? 1,000 grams. So 1,000. What is the C? What is the C? The C, it is 4.2. And what is my temperature difference? The final minus initial, so it is 25 minus 20, so it is 5. So I have 21,000 joules for every 1 gram of. Okay, what if I want to check it for the marshmallow? The Q is equal to MC delta T. That's I have how many grams I have? 5,000 or a sample of marshmallow containing was burned in a kilometer containing 2,000 and temperature of water based on the data. Okay. $1,000 grams of water. Mr. Do I see the sample of the water or the substance that I have burned, or do I see the water itself? So somebody replies to me here, I choose 1,000 يا مستر. لكن هنا I choose what? Do I choose 2,000 ولا I choose 5؟ أنا بختار 2,000 ولا بختار 5 يا مريم؟ ها؟ بختار 1,000 ولا 1 جرام؟ I choose the water صح؟ مش أنا في الام سي دلتا تي لو كنا نسينا باخد الام دي is the mass of the water. Don't forget mass. You don't choose the 5. This 5 I will use it later when I try to find the number of moles. So it is 2,000 multiplied by 4.2. In case you forgot, if you are making Q equal to MC delta T, this is the mass of the water, not the mass of the substance that you are burning. The mass of the substance you are burning, you will use later when you try to make the delta H equal to Q over N. That's the Q over mass, molar mass. What is this mass? This is the substance that you are burning, or the fuel. So on 2,000 multiplied 4.2 multiplied by what? By the change in temperature is this time is 35 into 25, so 10. So you got 8,400 joules per 1 gram, per 5 grams of marshmallow. Right, Mr. I need to compare 1 gram of cashew or 1 gram of marshmallow. So I need to change this into 1 gram. So I'll divide it by 5. So I will get 6800 joules per marshmallow. So when you combust the cashew, أنا كنت متهيألي العكس. The cashew will have more energy, for 1 gram more than marshmallow. So it has more energy because it produced more energy for 1 gram. We have compared 1 gram with 1 gram. That's why we divided it with 5. Okay,
Mister?
first, yes.
What sheet is this?
The same reply. This is a mixture of questions from past exams.
Oh, okay.
Okay.
Thank you.
Based on the data below, which of the following liquid substance has the weakest intermolecular forces? So let's try to remember how can we find this. Okay, Mr. In order to look at the intermolecular forces, I have to compare the equilibrium of vapor pressure. So does anybody know what is the relationship? How can I know which one has the strongest intermolecular forces? The relationship between IMF and vapor pressure is what? Directly proportional or inversely proportional?
Inverse?
Yes, it's inversely proportional. So the more intermolecular forces you have, the lower vapor pressure you have. So I'm going to look at HCHO because this one has the highest vapor pressure. So this one will have the highest vapor pressure, will have the lowest intermolecular forces of attraction. Okay, next one is trying to remember the bond energies. Calculate the delta H for the following reaction. N2 plus 3H2 give us NH3. So I'll try to draw my compounds fast so that I can get the number of bonds. The N is triple bond with another N. The H makes single bond with H, and it's repeated 3 times because there is 3 moles. And there is 2 of the NH3. This is repeated twice. So basically, I need to find the bonds broken and subtract it from the bond formed. So delta H is equal to the bonds, sum of the bonds broken minus the sum of the bonds formed. Okay, so can you try to do it for us, Yazid? Can you remind us, Yazid, how to do this bonds broken? So I have here N and N. So I have one time only of the 941. So 941. And I have H 3 times. So I have 432 multiplied by 3. And then I will subtract this from the bonds formed. The bonds formed I have 6 times from the bond between the N and H, which is 391. So basically, I have 2,237 subtracted from 2, 3, 4, 6, and this equivalent to 109, negative 109 kilojoules. This is an exothermic reaction for sure. Type identifies the strongest force that must be overcome to melt. In ice, the strongest force means that the most important intermolecular force in this. So let's take one by one. Yasin, ice, what is the strongest force that is available in ice? Ice, mister, I have 2 types of bonds. I have covalent and I have hydrogen bonding. So hydrogen bonding will be the strongest one. I have LDF21 and I will not mention it. And then K2SO4. Miriam, what's inside K2SO4?
Iron bonds.
ionic bond. Then I2, Julian, what's inside the I2?
Covalent bond.
Okay, there is other bonds which are facing me before the covalent bond. LDF, correct. So I have LDF, I have London dispersion forces. That's between the molecules before I face the covalent, okay? And Nadim, what's pH3? So pH3 is a polar molecule. Huh? What kind of bond it has? Hadiyab Abdullah. Mariam, what's pH3?
Dipole.
Dipole. So it is dipole. We always remember pH3 and NH3 as being similar, pyramidal shape, both of them, but the NH3 has hydrogen bond and this one does not have hydrogen bond, so it's only a dipole. So calculate delta H for the reaction C3H8 plus 5O2 give us 3CO2 plus 4H2O. Giving the following delta H F in the kilojoule per mole. Okay. So what is the equation for this one to find the delta H of the reaction? I have the delta H of formation in kilojoules. What is the delta H of the reaction equal to? مريم ممكن تفكريني what's the H of the reaction equal to what? Sum of
the entropy of the products minus the reactants.
تمام. Delta H of formation of the products minus delta H of formation of the reactants. The products that I have are carbon dioxide. So I have minus 390 for the carbon dioxide. This is into 3 times. So 3 multiplied by negative 390. And this is added to 4 times the water. So 4 multiplies by minus 286. And then I will subtract this from the delta H of formation of reactant. I have only C3H8 and it's 1 mole. So it is minus 100. And then oxygen is an element, so of course it is 0. That's equal to plus 100 for sure. So the value that I will get is minus 2214 kilo. So 100 centimeter cube of HCl was mixed with sodium hydroxide at 20 degrees Celsius in a coffee cup calorimeter. The maximum temperature recorded due to the reaction was 26. Calculate delta H for the reaction H plus and OH minus give us H2O. Assume that the density of solution is 1 gram centimeter cube. In this reaction, I have delta H is equal to negative Q over N. Q again is equal to negative MC delta T over the number of moles, which is C multiplied B. As remember before, when you mix two solutions, the N is equal to the C multiplied by V for the limiting reagent. For the limiting reagent, if they have the same number of moles, then I will choose any of them. And I can see I have the same number of moles because here I'm multiplying 100 by 1, and here is also 100 by 1, by 0.1 by 1. So I have the same number of moles in both of them, so you can just choose any of them. There is no limiting and excess. The negative M is the negative of the mass of the water, so that's negative 1. I don't have that. I have only the density, which is 1. And do I have the mass? Yes, I have 100 centimeter and 100 centimeter. So 100 plus 100, that's equal to 200 centimeter cube. And since the density is equal to 1, so that's equal to 200 grams. So I have minus 200 grams multiplied by C. C is equal to 4.2 joules. And multiplied by the difference in temperature, it was 20 and become 26. To 26 minus 20, that's equal to 6. The concentration of the solution is equal to 1 multiplied by the volume, which is 100 divided by 1000. When you do this, you get minus 50.400 joules per mole. And if you change it into kilojoules, minus 50 kilojoule per mole, and don't forget the negative charge for sure. So if equal masses of the following compounds undergo complete combustion, which will yield the greatest mass of carbon dioxide? There is question number 16 first. What volume of 0.50 molar HCl is needed to neutralize exactly 20 centimeter cube of calcium hydroxide? And before we do this, we have to make the balance of the equation. زي السؤال بتاع الفانيديوم اللي كان بيجينا قبل كده كتير. So this is HCl reacts with calcium hydroxide. This has to be balanced to form H2O plus calcium chloride. When we balance, we will get 2HCl and H2O, H is 2, and the oxygen is 1, H2O. So this is H2 calcium chloride plus 2 H2O. So there is 4 hydrogens and 2 oxygen. It's balanced now. So the ratio is 2 moles from the HCl together with 1 mole from the calcium hydroxide. So number of moles is not equal to each other. The number of mole of the acid is equal to 2 multiplied the number of mole of the base. So in order to make this one equal to this one, you must multiply this one by 2. And الرقم دوت أكبر من ده مرتين. This number is 2 times bigger than this one. So if you want to make them equal, you have to multiply this by 2. أو زي ما اتفقنا قبل كده إن أنت you will just divide this one by 2, whatever is easier for you to remember. So multiply this by 2 to be equal to the HCl. So you will say C of multiplied by V of the acid, C of the acid multiplied by V of the acid is equal to C of the base multiplied by V of the base. The concentration of acid is 0.50 and the volume is unknown, and the concentration of the base is equal to 0.020 and the volume is 20 centimeter. You can leave it as 20 as you will get your answer is in 20 also. So volume of acid is equal to 0.020 multiplied by 20 over 0.5. You will get 1.6 centimeter cube. Okay. What are alloys? 14, this is easy, 14.2 grams sample of certain diatomic gas occupies 4.93. Identify this gas. If you want to identify this gas, means you need to find its molar mass. So you can find the molar mass by saying that BV is equal to nRT, and the pressure multiplied by volume is equal to mass over molar mass multiplied by RT. So if the unknown is the molar mass, you can put it up here. MR بتساوي mass over PV multiplied by RT. Plus you have all the given. Pressure mass is equal to 14.2. The pressure is equal to 1. The volume is equal to 4.93. The R is equal to 0.0821 or whatever is given to you in the exam. And then the temperature is 27 plus 273 to change it from Kelvin into, from Celsius into Kelvin. Then you will get answer equal to 35.5. And this is the atomic mass of chlorine. So this is chlorine. Another question. This is easy. Okay, how do the size and charge on ions generally affect the value of the lattice energy? We know that the smaller the size, the bigger the lattice energy, and the bigger the charge, the bigger the lattice energy. We know this from the equation we have said many times. How to compare LIF and KF? The LIF is +1 and K is +1. F is -1 and F is -1. So since both of them has the same charge, I will look the one which has smaller size. Li plus is smaller than K, so it has the stronger lattice energy and it is more exothermic. Na +1, Cl -1, Na +1, and I -1. Again, the Cl -1 is smaller than the I -1. So lattice energy of NaCl is, of course, stronger than that of the NaI because it is smaller. MgO and Na2O, this is easy because magnesium is +2 and sodium is +1. So this is more charged. So magnesium oxide is of course stronger than Na2O. Calcium is +2 with -2, and here +2 and -1. So calcium oxide is more charged, of course, than the calcium hydroxide. So it's also strong. Atomic radii, graph presents, this is all repeated. Okay. A chemist carries out a reaction to form a gaseous chemical which could have either one of the formulas. Don't worry about this one, and chromatography will pass also. Phosphine is produced when phosphorus and hydrogen gas are combined to form phosphine gas. If 2 moles of phosphorus, 3 moles of hydrogen gas are reacted, what is the maximum number of moles that can be produced? This one you can pass also. Energy profile for energy change resulting from burning of wood. So just draw any exothermic curve. Draw the lowest structure. We'll just remind together very fast the lowest structure of ASH3. So I have here ASH3. Let's see. Like all the same elements of the same group, it's pyramidal. The carbon dioxide, that's very easy, carbon dioxide. And then I have silicon, sulfur hexafluoride. He's asking also about the geometry. So this course is linear, and this is non-polar for sure. This is trigonal pyramidal, and this is polar. That one is octahedral, and it is non-polar. Do I have also CH4 is tetrahedral, and it is non-polar. What do I have also? Okay. So we'll have a short break, and after this break, we'll get to focus more on. Okay, we'll focus more on the rate of the reactions and solutions, as they were the last things that we have taken. Just take a few minutes break, and we'll come back. Okay, now we'll focus a little bit more on the chapter 12, as is one of the latest chapter. Okay, and we'll see some questions about it. Bismillah. You can see the screen now. Okay, explains the effect of the heating. Why does the heating increases the rate of a chemical reaction? Select all that apply. It increases the average energy of the reactants. It increases the average speed of the reactants. Increases the number of collisions that poses the threshold energy needed to form new products. دايما مركز على الحكايه دي. Please focus this too much. If he is asking about the effect of increasing the concentration or the effect of increasing the pressure, then you are going only to talk about the collisions. So the collisions will be more, and the successful collisions between particles is going to be more. But if he asked about the increase in temperature or decrease in the temperature, then you have to mention two things: the collisions plus the energy. The collisions plus the energy or the kinetic energy. Now the particles not only collide with each other more, but they collide with enough energy. And enough energy, he mentioned here, saying that the threshold required to form new products or whatever. This means that it is more than what? More than activation energy. This is many different things to say that it is equal to or more than the activation energy. And then, of course, it increases the average energy and the average speed of the particles, also of the reactants. Does it lower the potential energy of the activated complex? No, مش دعوة. This is for the catalyst only. This will be mentioned only for the catalyst. It provides an alternative, easier mechanism for the reactants to follow الكلام ده, which not applied for anything of that. So again, for the last time, please take care. If you are talking about temperature, don't only speak about the collisions. You have to mention the collisions and that the energy of the particles now is enough to make the energy more than the activation energy. The same question that's repeated every time to find the rate of the reaction below in terms of change in concentration of C and delta C. So 3A plus 2B plus give us 4C. هل في أي حد جات له فرصة إنه يسأل التيتشر ليه السؤال دوت الإجابة بتاعته بتبقى كل مرة كده؟ جيم ياسين. Anybody ask it? Why it's showing like that? Why it's not showing?
Sure, I didn't ask.
Okay. Nadim,
I didn't
Yassine.
ask it.
Okay. Anybody ask it why they are insisting that the rate of reaction is in terms of C is not like what we know. In terms of C, it should be -1/4. هل حد سأل السؤال ده؟ ياسين؟ أي حد؟
مستر عشان لو كان بيقول concentration of all the reactants and products you put the coefficient and the signs, بس لو قال C بس you should put the without the coefficient.
Even if it is equivalent to that. احنا بنيجي نعمل calculation بنحسبها ازاي؟
هو for C أصلا it's positive عشان in the beginning it's 0 وفي الآخر
I'm sorry, so it should be plus كده. ولما بنيجي نعمل calculation بنعملها كده اهوت. Why he is saying like that? So هو بيقول لك كده. قول يا ياسين.
قالت لنا عشان في سؤال تاني زيه there's like equal signs
equal to plus 1/4 لما يكون بيسأل على ايه؟
البرودكت والرياكتنت والتو رياكتنتس.
اوكي لما يكون بيسأل على كله
اللي انت فيه.
when he is asking about everything mention it equal to plus 1/4 and
when he's asking for one only.
Okay. So I will say like plus 1/4 equal to negative 1/3 delta C على الدلتا تي بتاع سوري ايه دلتا ايه على الدلتا تي concentration و equal to -1/2 change in B على change in T صح؟ طيب اوكي. طيب next one, the rate constant of a first order reaction was determined to be 3.41 multiplied to 10 to the power of -3 S-1 deduce its half-life. And on that T half of first order reaction is fixed and is always equal to ln 2 divided by K. واحنا قلنا ln 2 on the calculator will give us a number that we memorize is 0.693 over 2 and that's equal to 203 seconds. طبعا اللي ما حفظش الايكويشنز الانتجريتد بليز start now memorizing them. For the T half of everyone, how do I know the rate of everyone's integrated law for everyone? How do I know the T half of this one? And the graphs. ثلاث حاجات I have to memorize them: the graph, the T half, and the equation integrated law. So next one, given the following reactions, the acceptable reaction mechanism is. So دايما بشوف لو أنا عندي الإيكويشن ما فيهاش mechanisms, there is no mechanisms, I will just mention whatever experimentally is found. But if there is mechanisms, then I have to check the slow reaction or the fast reaction. I will go for the slow reaction. The slow reaction is telling me N2O2 plus H2 give us N2O plus H2O. This is the slow reaction. This is the slow reaction. So I can get the equation from it. I can just get the equation from it. The rate law is equal to what? تاني بقول لو كان بس في only if there is mechanism and multiple steps. So it's equal to K N2 O2 فين الرياكشن يا مستر؟ in الرياكشن اهو sorry is the reaction. So NO to the power of NO to the power of 2 and H2 to the power of N2 to the power of 2 and NO to the power of 2. ليه يا مستر جبت NO من باور 2 منين؟ اهي ابص عليها this is NO يا مستر power of 2. ال H2 يا مستر مش موجوده هنا. احنا جبنا ال NO من هنا عشان هي مش موجوده هنا فجبنا الايكويشن بتاعتها 2 وبصيت على ال H2 لقيتها هنا power of 1. خد بالك you are looking at the rate from the mechanisms. You are getting the rate from the mechanisms, not from the general equation. Okay, so take care. I don't get H2 to the power of 2 because I'm not looking at what? I'm not looking at the 2 here. ما ببصش على المين equation. I'm looking at what? At the step. I'm looking at the step. So H2 here is to the power of 1 because there is 1 mole here. NO is here is 2 because it's to the power of 2. طب لو كانت يا مريم الايكويشن هنا 3. So I take 2. Again, I'm taking the coefficients منين يا مريم? From the steps or from the steps? Yes, 2 from the steps, not from the main equation. I'm getting it from the steps. وبس في حالة ايه يا مريم؟ في حالة ايه بس؟ في حالة لما يكون في mechanisms. If there is no يعني ايه مستر في mechanisms؟ يعني لو جاب لي equation عادية وقال لي NO plus CO gives so and so and find the rate مش هقول له بقى rate is equal to K and NO and CO. No, I cannot say like that. I will tell him that I can get it only from the experiments. Only from the experiments. طيب. Acceptable mechanism for the reaction 2H2 plus 2NO give us N2 plus 2H2O. Drag and drop the correct item to complete the following sentence. The species is acting as what? N2O2. So let's see again. What is the N2O2? It's an intermediate. ليه intermediate? We said the intermediate is something that appears and then disappears. بص كده. This is the reactant. I was having NO. So I was having NO. And H2 is a reactant. N2 is what يا عبد الله? It's a product. هل هو موجود في الأول؟ No. H2O is a product. موجود في الأول؟ No. طيب ايه هو الانترميديت؟ something that appeared and then disappeared. هل هو موجود في الرياكتنت؟ لا. هل هو موجود في البرودكت؟ لا. So it is something that appeared and disappeared. Okay, Julian, where is the catalyst here? Can you give me a catalyst here? Is there a catalyst here? No, there is no catalyst here. I don't see any catalyst here. Okay, what about H2? What is H2? H2 is what? A reactant, صح? Because it's at the beginning and disappear. But what about NO? Reactant. What about N2? Product. What about H2O? Product. Right. The half-life of a nuclear decay was found to be 12.3 hours. How long does it take for 38% of the initial amount to decay? يعني I started with 100% ياسين. How much do I have at the end? How much 62. Do I have at the end? 62. ممتاز. Because he told me I have decayed 38 يا عبد الله. I have decreased 38%. And how much do I remain? 100 minus 38, so I have 62 at the end. So the initial concentration was 100%. The concentration after a certain time is 62%. Why? Because you have decomposed or decayed 38%. طيب بيقول لي the duration needed, what is the time required يا مستر? First thing to ask about the Julian, what is this? Is it first order or second order or zero order? Because he did not mention here. Did he say, is it first or second or zero?
First.
First. Why it's first? Why it's first? Because we said it's a nuclear decay. So take care. You have seen the recording for this one. The nuclear decay is any decomposition of any substance is what is first order. Because he is not going to tell you in the exam and you will be lost. Which equation do I use? Do I use first or second or zero? So I will use the first order. So I know for the first order, T half is equal to ln 2, or let's say 0.693 divided by K. Okay, what is the T half, Mr.? He told me the T half is 12.3. What is the T half? The time required for the concentration to decrease by half. الوقت اللي محتاجه عشان يخس النص بتاعه. So it's ln 2 over K. طيب ما انت عايز تجيب ال K، خلاص ال ln 2 اللي هي 0.693 بتساوي ال K multiplied by 12.3. So K is equal to 5.64 multiplied 10 to the power of negative 2. طيب انت بتقول ان اللين بتاع الكونسنتريشن، what is the equation بتاعتي for rate؟ what is the equation of the rate؟ جماعه اللي ما شافش الريكوردنج بتاع السيشن بتاع الانتجريتد لو you must see it. It's very important session and very important questions. What is the equation؟ حد يقدر يقول لي الايكويشن بتاعت الفيرست so I would say ln the concentration at the final which AT is equal to negative K multiplied by T زائد what؟ ln at the initial concentration. الايكويشن دي مستر اعملها اجيبها منين؟ I have to memorize it. This is the integrated rate law for the first order equation. عملنا جدول وعملنا this session is recorded and submitted. It's very important to see this session. ln AT. طيب المستر ال AT انت بتقول 100% و 62 so I can say ln 0.62 is equal to negative K. We found the K from the T half, 5.64 multiplied 10 to the power of negative 2 multiplied by the T. How much time? هو التايم ده اللي انا عايز اجيبه. This is the T that I need to find. Plus ln of the final concentration او the initial concentration which was A0 اللي هي اللي انت قلت عليها 0. قلنا عليها equal to 1. لو ديت equal to 1 so this is 0.62. So by finding the T I can say it's equal to 8.48. يعني يا مستر في كل half life بنزل 12.3. أنا كنت 100% بعد أول half life هنزل أبقى 50%. يعني بعد ما يكون عدى قد إيه؟ 12.3 hours. 12.3 hours. مستر أنا مش هعدي 12.3 hours، أنا هعدي بس 8.48 منهم. أنا هعدي 8.48 يعني البرسنتج اللي أنا هقول لها هتكون less than 50 صح؟ أو less than أو البرسنت أقل من النص. So it will be only 36%. So I will change from 100 into 62%. أنا آسف 62%. So لسه ما وصلتش الهاف، لأن الهاف بياخد قد إيه؟ 12.3. أنا هاخد 8.48 يعني خسيت وقت أقل بس من الهاف لايف. طيب in such kind of equation to study the kinetics of the reactions I will see Nadim two experiments in which one of them is changed and one is not changed. So I have 1 and 2. I have changed this one the y and the x is not changed. هلاقي ان انا لما قللت ده النص 4.2 changed into 4.2 ولا ما اتغيرتش it not changed. So is it dependent يا نديم on y ولا it's not dependent on y؟ The rate is does not depend on y, so it is k multiplied x to the power of كام؟ I don't know x yet, but I know that y is to the power of 0, so I will not mention it. What about the x? When I change it, yeah, Mariam, when I change the concentration of 0.72 into 0.24, what happens to the rate of the reaction? The rate has decreased by dividing over 3. So I divided it over 3. Then I will see what happened when I change it 0.72, 0.24, what happens to the rate. So I will also divide 4.2 multiplied 10 to the power of -3 على 4.7 multiplied 10 to the power of -4. Can anybody see what happens when you divide this one by this one? (4.2 multiplied 10 to the power of -3 على 4.7 multiplied 10 to the power of -4.
9.
It's 9. So this means, yeah, Mister, when you decrease this one by 3, you decrease this one by 9. So this means that x is which order?
2.
2. انت قلت لي يا مستر when you do an effect for 1 and the effect is squared يا عبد الله, so this means that it is second order. So what happened to the effect? نفس الeffect اللي انا عملته هنا, I have squared it. Instead of dividing by 3, I divided by 3 to the power of 2, which is dividing by 9. So it is second order for x and 0 order for y. So when I write the equation, I will not even write y. It's k to the power of x squared, and I will not mention y. Okay. So it is second order for here and 0 order for here. And what is the overall? How do I find the overall? Yeah, Abdullah, I do what? Addition of both of them. So I add both of them, 2 and 0. So the overall order is 0. What if it is 2 and 1? Yeah, Abdullah, I will say the overall is, just do addition. So overall rate will be third order. Okay, for the reaction H2 plus Cl2 to HCl, the following differential law was determined. So I found that the rate is equal to pH2 multiplied by to the power of 2 PCl2. خد بالك نفس الكلام اللي انا بقوله على الكونسنتريشن هقوله على البريشر. This is to the power of 1 and this is to the power of 2. Choose from the list correct unit of the rate constant. مستر انت بتقول الريت بيساوي البريشر of H2 to the power of 1 multiplied by the pressure of Cl2 to the power of 2. So what is the K? K بتساوي rate divided by the pressure of the H2 multiplied by the pressure of Cl2 squared. What is the unit of rate يا مريم? The unit of rate is, خد بالك ده مش concentration, ده ايه؟ pressure. So what is the unit for pressure? It's atmospheric change per time. And what did he say? The time is -1. So per minute. So I will say ATM over minute. What is the unit for pressure? It's ATM. What is the unit of pressure square? Is ATM square. So I will cancel this one with this one, and I remain with minute, 1 over minute multiplied by ATM squared. So it is minute -1 and atmospheric -2. This one we have answered before, it's easy, and this one also. Just try to see some of the ones that we didn't do. Now this one we found that the change is multiplied by 4 and this is multiplied by 4. So it is, this is 4 and 4. I don't see numbers very well. With respect to NO, when I change it NO and there is no change in 0.02, I can see that it is almost multiplied. This is divided by 2 and this is smaller. So I can know that it is divided by 4. How do you know, Mister? Because he said it is second order. What does second order mean, Ya Abdullah? Means that if you divide this by 2, you will divide this by 2 squared. So 2 squared, and 2 squared is equal to division by 4. Right, what about the other one? When you divided the Cl2, when you multiply Cl2 by 4, This one was also multiplied by 4. So what order is it, Ya Abdullah? If this is multiplied by 4 and this is multiplied by 4, so regarding Cl2, it is first order. So it is first order for Cl2 and second order for NO. So what is the overall order? It is 3. Right. This is a reaction in which A moles of A reacted with B moles of B. First order reaction with a rate constant K is equal to 4.95 multiplied 10 to the power of -4 S minus 1. Don't forget the units. نسيت أقول الunits. So for zero order, first order, second order, you have to know the graph, the units, the integrated law, and the T half. الأربع حاجات دول لازم أعرفهم فيهم كلهم. Don't forget the units of everyone. So K equal to 4.95 multiplied 10 to the power of -4. اليونت بتاعتها is S minus 1 بتاعت الكي دايما. If initial concentration A0 كانت 0.500, what is the concentration after time AT with time بتساوي 120 seconds. So again ln A بتساوي negative KT plus ln A at the time 0. So ln A at time T. Then I will find which one do I need to find the A concentration after a certain time. The concentration here was 0.5, the time was T, and the K, we have it. So I can just plug in my numbers. Once ان انت حفظت الايكويشنز، كل الخطوات اللي بعد كده بتكون خطوات سهله جدا لدرجه انها تفهم. اوكي. Select the graph that represents the first order reaction. ايه ده يا مستر؟ وانا لازم ابقى عارفه طبعا. ايه الجراف بتاع الفيرست اوردر؟ ln A versus time is a straight line. Nadim, what is the curve for the second order? This is first. What is the curve of the second order?
So can you repeat the
Nadim?
question? It's the second order, yeah.
What is the curve for the second order? Is that
The curve. Sorry, I don't remember.
1 over حد فاكر؟ 1
Wait.
over
I think I remember.
1 over the concentration, صح؟ Miriam, what is the curve? Second order. The reciprocal of the curve.
1 over
مظبوط.
concentration.
Over
time.
concentration at time versus time. And what is the shape of the curve? Is the line going like that, Nadim, or going like that? Yassine, is it going up or going
The
down?
line is going up. It's going
It's
up.
going up. ممتاز. It's going up. But how come this is reactant and the concentration should increase? Yassine, how come it's going up? Because it's not the concentration of the reactant. It's what? The reciprocal of the concentration. So concentration of reactant decreases by time, but the reciprocal increases by time. Watch out for this curve. Like this one. So this is second, yeah, mister. This is second. Okay, what is this first curve? حد يعرف? What is this first curve? This one. What is this curve?
It's zero order.
This is zero order. Zero order is the concentration versus time. The concentration versus time. The second order is 1 over the concentration versus time. The first order, the ln or the natural log of the concentration versus time. The second order integral equation is 1 over the concentration is equal to KT. انت بتعرف الكلام ده منين يا مستر؟ انا حفظت الايكويشنز دي. نحفظ الايكويشنز دي لازم احفظها. قلنا تاني هقول تاني. The equation, the T half, the unit, and the graph of every one of them must be memorized and separated from the other. Then I have what? I need the concentration of A. The K is equal to, give your answers. How much time? He needs the time. So he giving me A and A0 and the K and needs the time. Select the correct equation describes the integrated zero order. A is equal to negative K plus A initial. أمال دي إيه يا مستر؟ لا دي أي كلام فاضي. أمال إيه دي يا مستر؟
Second
This
order.
is the second order. And this is what? This is nothing but. Oh, sorry. Sorry, nice. Relax. This is second order. This is second order and this is not. اوكي طيب احنا ايه الحاجات اللي احنا عايزين نعمل فيها الريبيتيشن للايكويشن؟
مش second order هي K مش negative
I
K.
will I will show you the curve عشان في ناس قاعدة هنا بتقول لي يا مستر انت بتتكلم في ايه؟ ثواني. I will show you the table. Is this the one? No. This is chapter 11. Okay, I'll send it later not to waste the time. شكرا يا ياسين وفي حاجة تانية أنا نسيت أقولها كمان. It's K plus 1 وفي حاجة تانية ياسين قلناها كمان مظبوط كده يا ياسين؟ K plus 1 على A مظبوط؟ اوكي وفي حاجة كمان 5 ده في حاجة 5 كمان يا نادين. What is that؟ ها؟ The slope don't forget the slope also. So the graph, the unit, the low and TF and the slope you have to know the slope. Slope for first order is negative K. The slope of the second order is K, positive K. صح يا ياسين؟ اوكي. الكيرف بتاع exothermic reaction طبعا exothermic endothermic this is very easy. Following is the Boltzmann distribution curve. Boltzmann distribution curve, the amount of energy of the particles increases, so more particles will have higher energy than before. So if you start at the beginning at a cold temperature, then you increase that temperature, what happens؟ بعض من البارتكلز اللي كانت التمبريتشر بتاعتها كولد هتروح من هنا والتمبريتشر بتاعتها تزيد فالاريا اوف ذا كيرف increases becomes here. طب زودت التمبريتشر كمان من الريد للهوت البارتكلز اللي كانت هنا التمبريتشر بتاعتها قليله زادت التمبريتشر بتاعتها دخلت في الميديوم تمبريتشر واللي كانت في الميديوم راحت من هنا وبقت في الهوت. So the curve moves to the right. The curve moves to the right. اول كيرف كان كده بعد كده شويه من الاريا اندر ذا كيرف بتنزل والكيرف يبقى كده وبعدين يمشي كمان التمبريتشر تزيد الكيرف يبقى كده كل شويه الاريا او اندر ذا كيرف بتروح من اللو تمبريتشر للهاي تمبريتشر. This T1 which is lower than T2 which is lower than T3. So as you go to the right the temperature increases. Okay. I wish I can continue but I have another session for grade 11. So I'll see you next time inshallah. I'll agree for another session. Thank you everyone.
So will we have a lesson tomorrow?
Yes, I think we'll have a lesson tomorrow.
What
I
time?
will agree with the time. Maybe it will be afternoon also. Not morning. Okay, maybe it will.
Okay, shukran.
Thank you so much and see you next time inshallah. Thank you Julia. Thank you Mariam. Thank you Mariam. Thank you.
Thank you.
Thank you Abdul. So much. Bye-bye. شكرا عبد الله. شكرا مريم.